Okay, this is chapter 3, lesson 3.6, compound inequalities. Okay, our objectives here are to solve and graph inequalities containing the word and to solve and graph inequalities containing the word or. All right, so for compound inequalities, it consists of two distinct inequalities joined by the word and the word or. So for our first example, this is an example of an and inequality. And our second example is an example of an or inequality. Okay, and as you can notice, an and is filling in, or its solutions are included in a shared region of the inequality. An or inequality is what's left on the outside. So it goes into infinity on both sides. So there's just this one section that is not included in the solution, okay? So when we do more of them, that will make more sense, but that's basically what you need to know. And is including, and it's like a finite section, or is infinite, okay? And there's one section that's not included. Okay, so writing a compound inequalities. What compound inequality represents the phrase and graph the solutions? So all real numbers that are greater than -3 and less than 6. So all real numbers we're going to go ahead and substitute x for, and it says that they're greater than -2 and less than 6. So x greater than -2 and x less than 6, okay? Now, from here, what I want you guys to do is we're going to flip this first one. What we want to do is get the x's next to each other. So this is going to be -2 is less than x, and x is less than 6. Once we've done that, so we just flip this, okay? Once we've flipped it, okay, all we need to do is write it as -2. We combine the x's, is less than x, is less than 6, okay? So now I've got one compound inequality. Remember, we can only do this for and here's -2, here is 6. They are not greater than or less than or equal to, so we're going to put open circles, right, because they don't have the lines underneath. And x is going to be the region in between them, because it has to be less than 6, and it also has to be less than or greater than -2. This is an and example. Okay. B, all real numbers that are less than 0 or greater than or equal to 5. So this is going to be x, real numbers. So x is going to be less than 0, or x is going to be greater than or equal to 5, okay? So in this case, we don't flip it. So for or examples, we don't flip it, we just graph it. So here is 0, here is 5, closed circle at 5, open circle at 0. X has to be less than 0, so we're going to shade away or toward the outside. So remember or, and then 5, same thing. X has to be greater than or equal to 5. So we're going to shade in this direction. Okay? If you're using the Anthony method, see how there's this inequality. It matches up with this arrowhead, and same thing over here. X is less than 0, matches up with that arrowhead. Okay. Writing a compound inequality. Okay, let's do two more. So A, all real numbers that are greater than or equal to -4 and less than 6. So x is going to be real numbers that are greater than or equal to -4, and x is less than 6. So from here, remember, we want to flip this. So this is going to be -4 is less than or equal to x, and x is less than 6. So -4 is less than or equal to x, which is less than 6. Here's -4. Here is 6. open circle at 6, closed circle at -4, and this is an and problem, so we are shading in between. Okay, and let's do B as well. Oops, this was A. For B, all real numbers that are less than or equal to 2 1/2 or greater than 6. Okay, so X is less than or equal to 2 1/2, or X is greater than 6. Immediately we graph it. Here's 0, here's 2 1/2, here is 6. X has to be greater than 6, open circle, shading to the right, because it's greater than, so all the values greater than 6 are included. And X has to be less than or equal to 2 1/2, so closed circle because of the equal to. And we're shading in this direction because it's less than or equal to. Okay, so everything less than 2 1/2 is also included. So only this region in between 2 1/2 and 6 is not included. Okay, solving a compound inequality involving and. What are the solutions of -3 less than or equal to m minus 4 less than -1? And we're going to graph those solutions as well. So from here, what we do, guys, is what we have to get our variable alone. So like we normally did, m is our variable, so we want to get rid of that -4. So what we do is we add 4 to everything, okay? You have to add 4 to all 3 sections, okay? So this is -3 plus 4. This is going to be 1 is less than or equal to m, which is less than 3. And we also have to graph the solutions. So let's go ahead and graph it. Here's 3, here's 1, closed at 1. M is greater than 1, but less than 3. And 3, there's an open circle. Okay, writing and solving a compound inequality. So to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. You scored 86, 85, and 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? Okay, so we earned 86, 85, and 80 on the first 3 tests. And we're going to add the score of our last test, which is unknown, and we're going to divide by 4. That'll give us our average. And it says it must lie in between 84 and 86. Okay, so this average must lie in between there in order for us to get a B. So we're going to find out the range or the possible grades that we need to get on the 4th and final test in order to get a B in the course, okay? Now, I noticed that X is in the middle, and we want to get rid of all of the numbers around it. But before we can do that, we have to get rid of this 4. So we're going to multiply both sides by 4. Actually, all 3 sections by 4. And then we're going to get 4 times 84. 4 times 84, which is 336, is less than or equal to 85 plus 86 plus 80 is 251. Remember, these 4s are canceling, plus x is less than or equal to, and then 86 times 4 gives us 344. From here, we have to subtract 251 minus 251 minus 251. And what we're going to get is 93 over here, x by itself, $85 over here. So our grade for the last test needs to be between an 85 and a 93, but it could be an 85 and a 93 as well. Okay, solving a compound inequality involving or. What are the solutions of 3t plus 2 is less than -7 or negative 4t plus 5 is less than 1? So for the and ones, right, we did the same thing to all three sections. For or, we are going to do different things to each section. So we're going to solve them separately. So this is going to be 3t plus 2 is less than -7. We're going to subtract 2 from both sides. We're going to get 3t is less than -9. Then we're going to divide by 3. And we're going to get t is less than -3. That's 1. Second one, we're going to do -4t plus 5 is less than 1. We're going to subtract 5 from both sides. -4t is less than -4. Divide by -4, divide by -4. Remember, when you divide or multiply by a negative, you got to flip that sign, so it's going to be t is greater than +1. And this is an or. So when we graph it, let's keep that in mind. Here's -3, here's 1, open circles at both. T must be less than -3, so we're going to shade this way. And t must be greater than 1, so we're going to shade this way. All right, solving a compound inequality involving or. Here's some more. -2y plus 7 is less than 1. We're going to subtract 7 from both sides. We're going to get -2y is less than -6. Divide by -2, divide by -2. Don't forget to flip your sign. And this becomes +3. (4y minus +3 is less than or equal to -5. What we're going to do is we're going to subtract 3 from both sides. 4y is less than or equal to -8. Divide by 4 to both sides. Y is less than or equal to -2. When we're plotting this, this is an or. Here's our graph. Here is 3. Here is -2. Remember, y has to be less than -2 or equal to, so it's going to be a closed circle. And less than, so it's going to be shaded to the left. And then y equals y greater than 3. So at 3, open circle, and we're shading to the right. Because this is an or problem, we are shading on opposite ends, so we're good to go. All right, interval notation. This is very important, okay? So parentheses, we use parentheses when we're using a greater than or a less than symbol, and that indicates that the endpoints are not included. Brackets means that the endpoints are included, so those are when we're using a less than or equal to or a greater than or equal to symbol, okay? Infinity, so we use infinity when the interval continues forever in a positive direction, and we use negative infinity when the interval continues forever in a negative direction, okay? So if our inequality was x is greater than or equal to 2, that would be a closed or a bracket at 2, and then a parentheses at infinity, because it goes all the way to 2, and it goes to infinity. So that's our interval notation, okay? If x was less than 2, then at 2, we would have an open, or a parentheses, okay? And then at negative infinity would be the left side, okay? Interval notation for x has to be between 1 and 5. So parentheses at 1, and then 5, it's a bracket because it's a fixed, it can be 5, okay? 5 is included in the interval notation, okay? And then we've also got an or. So going from negative infinity all the way up to negative 3, not including negative 3, and then going from 4 to positive infinity. All right, so we're going to go ahead and try one of these. What is the graph of negative 4, 6? And how do you write negative 4, 6 as an inequality? Okay, so first off, let's graph it. Here is negative 4, here is 6. So we know that our answer does not go to infinity, so we're not going to be shading in any of the arrowheads, right? So, but we are including negative 4 because it's a bracket, so it's going to be a closed circle, but we're not including 6 because it's a parenthesis, so we're going to leave it as an open circle. We are going to be shading the region in between them, okay? So we're going to shade this area in between them. Perfect, okay? So it goes from negative 4 to 6, including it, okay? Because that's our left boundary, and this is our right boundary. All right, now let's write negative 4, 6 as an inequality. Well, we have negative 4 less than or equal to, because it includes negative 4. Let's put x, and then less than 6. Because it doesn't include 6. Easy enough. Okay, now we're going to do an or one. So what is the graph of x less than or equal to negative 1 and x greater than 2? Here's negative 1, here's 2. Negative 1 is included. X is going to be less than or equal to negative 1. 2 is not included, and x has to be greater than 2. And this makes sense because it is an or compound inequality, okay? How do you write that in interval notation? So our left boundary, let's start from over here. This is going to be an open parentheses, negative infinity, comma. It stops at negative 1 with a closed bracket, or parentheses at 2 because it's not included, to infinity. Okay, here are some check yourself before you wreck yourself questions. The answers to these are on the next slide. Go ahead and check them. And then we're going to finish up with our exit ticket. So compare the graph of a compound inequality involving and with the graph of a compound inequality involving or. Okay, so and is always the region between and it's finite. Or is the region to infinity and negative infinity and is not finite. Okay, here's your homework. Go ahead and get started. And yeah, good luck.